Okay, in this video I am going to show you how to draw a roof using roofing geometry. So the position of the roof is, for elevation, move down from the top of the sheet down 100 millimeters to the XY line, the ground line. Okay, that will be the wall plate of the roof. Okay, move in 60 millimeters from the left hand side to the bottom left hand corner of the roof. Okay, so it's down 100 and in 60 millimeters to the bottom left hand side of the roof. The length of the roof is 120 millimeters. 120 millimeters. Okay, now the plan is going to be situated 20 millimeters below that. So 20 millimeters below this XY line, draw in the top of the plan. Bring these 2 points down and measure the depth of the roof. The width of the roof here is 90 millimeters. So it's 90 millimeters from this point here to this point here. So I'm going to proceed to draw in, to ink in at least part of the elevation and part of the plan. So this is the bottom line of the elevation. And this is part of the plan here. So I have the plan drawn in here. So that's the plan, and this is the bottom of the elevation. Okay, so just to recap then, down 100 millimeters to the XY line, in 60 millimeters to the bottom left hand corner of the elevation. The length of the roof is 120 millimeters. I move down 20 millimeters below that for the top of the plan, and I also then give it a depth which is 90 millimeters. So the width of the roof is 90 millimeters. And then I proceed to draw on the outline of the plan here as a rectangle, and I've got the bottom of the roof here, the wall plate line of the roof. Okay, now it is a hipped roof, so with the pencil here I'm simply going to draw in 45-degree lines from each corner of the plan. Now, I've drawn in the 2 hips in the right hand side, 2 hips on the left hand side, and then where those 2 45-degree lines meet, here and here, that gives me my ridge line. I'm going to bring up those 2 points on the ridge line to the elevation. Now, the pitch of the roof itself is 45 degrees. So on the elevation here, simply draw it up at 45 degrees from the wall plate line here, and 45 degrees also from this point here. Okay. Now I can complete the elevation and plan. So completing the elevation here. And now the plan. So I have my elevation and my plan drawn in. Now I'm going to complete the end view very simply by bringing up these 2 points on the plan at 45 degrees. Okay, so where these 2 points now hit the XY line, I simply bring those 2 points up at 45 degrees. Now, so I have my elevation, my plan, and my end view. Now I'm just going to complete the end view there and put it in, instead of red, I'm just going to put it in black ink. Okay, so what we have now is the elevation, the plan, and the end view of the roof. So what I want to do is I want to unfold each of these sides here to see what the true shape of each of these roof surfaces are. Okay, I also want to understand, well, what is the true shape of this hip rafter here? Because when I look at it on plan, it isn't a true length, and when I look at it on elevation, it is not a true length. So how do I understand, how do I get to understand how I can draw this as a true shape? Okay, so very simply, I'm going to start with the development of the roof surface first. What I'm going to do is I'm going to try and pull this around onto the XY line. I'm going to use a compass to do that. I basically get this distance here. Now what that distance is there as a length, right? As a true length. This is not the true length of the hip here, okay? It's not the true length of the hip, okay? It's not the true length of the hip, because when you're seeing the hip here, you're looking in on the elevation here, you're not seeing it as a true length on the elevation. You're also not seeing it as a true length on the plan looking down at it, because it's inclined, okay? But what it is showing you a true length of is this common rafter here, okay? So this common rafter, that broken line I'm drawing in there, that distance as a true length is this distance here. Okay, so this distance, the common rafter length here, as a true length is this distance here. Because when I look in at 90 degrees to this red broken line here, I see this angle, 45 degrees. So that is a true length of this line. So what I'm going to do is I'm going to pull that around as a true length line of that common rafter. Pull it around. Okay. Now, I'm going to indicate this again using a red ink, and I'm going to show that using a French curve, just the pulling of that length around onto the XY line. Now using a French curve is very handy just to Obviously, if you're using coloring pencils or ink to go over any radiuses that you've drawn in with a compass. Okay. Now, what we're going to do now is we are going to bring this length down onto the plan. This distance here. Okay. And I'm going to bring this point here out to meet it. So we're using this as a swivel point, and we're pulling that around as a true length. We're pulling this over. Okay, so again, just to use the red ink here as a line, put it in as a full line here, as a full red line, this distance from there to there. Okay, that here is a true length of this line here. Okay, put as a red line here, distance from here to here. Okay, now if I connect them back, this here now, I've unfolded this, pulled it around as a true length line. So this point, going back to the role play points, okay, the corner points, 1 and 2. So this here is a true shape now of this surface. Now what I want to do is show obviously what this side is going to be when I unfold it. Obviously this side is going to be a mirror image of this, so that would suffice for this side here, and this side here, if I develop this, will suffice for this side here also. So very simply I can do just take the true length line again. So this true length line here, this now is a true length of the hip, by the way. I've not only developed the side, I've also developed the true length of the hip. So that measurement there is a true length of the hip. I pull that true length of the hip line around with the compass. Okay, and I then bring down the ridge point to meet it. At this point here, bring that down. Okay. Now again, I'm going to use the red ink pen to show that curve moving around. So that gives me this point here. Now again, what I've simply done is, if I put it down here as a broken line, this common rafter here, okay, as a length, true length, it's that distance. Okay, the same way as that common rafter, this is a true length line here of this common rafter. But it also, this gives me, again, this is the true length of the hip, swiveled around, going back to the same corner now of the roof here. That also gives me the true length of the hip. Okay, that's a true length of the hip here. And then all I have to simply do is bring the other points out from the ridge. So, again, I bring this point now horizontal. Bring the ridge point down. Gives me this point here. I'm going to push this drawing up a bit. So it gives me this point here. Okay, and this point goes back again to the corner. So again, just to indicate it with red pen. I'll bring this point out across here to show what I've done. So that's your common rafter. Plan. True length of the common rafter here. This is the ridge, and this is the true length of the hip. So what I have now drawn here, I have a true shape of this roof surface here, which will be the same as this one here. It's the same development. Okay, I also have this one here, the true shape of this roof surface here. Okay, so the next thing I'm going to show you is actually how to develop the actual hip rafter itself. Now I've already got the development here. This is a development of the hip rafter here. This is a development of the hip rafter here. This is a development of the hip rafter here. This is a development of the hip rafter here. This is the true length of the common rafter. This is the true length of the common rafter. This is the true length of the common rafter. Okay? So, I also have, if on elevation, I want to look at it on elevation, if I draw this line across here, so the common rafter, which is this, is the same as this and this and this. They're all the same, the common rafters. But if I look in on the elevation, the common rafter length, that's a true length. This elevation here is a true length of the common rafter, which is this here. Okay, and the same way it was here, this length of the common rafter on plan, this is a true length of it here on elevation. Okay, now 45-degree line here with regards to the hip. I'm just going to draw that up here. Okay, so what I'm going to do is, this here is the hip on plan, right? 4 hips. I'm going to now come up the rise at 90 degrees to that hip from the ridge point here. Okay, I'm going to come up the rise measurement. So the rise measurement, again, if I put it in red line here, so this point here, it's a ridge point on elevation to the XY line, that there is the rise. That's the rise of the roof. So that rise measurement, I'm going to take that rise measurement and what I've drawn here, this is the hip I'm going to develop here. I've drawn a line up at 45 degrees off that hip, which gives me, it's a 90-degree angle here. And I'm going to mark up my rise height. Okay? So I'm going to put that in as a broken line here. Okay, so that there is my rise. And I'm going to bring that point, top of the rise, back to the corner point here. Now, this gives me the true length of the hip. So that length there is the same as here, 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 here. Okay, so it's all the same length, true length of the hip. But what I'm going to do is I want to establish what is the dihedral angle. The dihedral angle of that hip. So I do that where I've got the rise here and my true length of the hip and the hip that I'm developing on plan here. I'm going to draw a line at 90 degrees, anywhere along the hip line here, 90 degrees through the hip on plan. Right, that's the hip on plan, and this is at 90 degrees to the hip on plan, which is a return at 45 degrees. Okay? Now I'm going to index this A and B, and I'm going to index this center point here as C. Okay, so at 90 degrees, I'm going to put my rule there on the development of the hip, and at 90 degrees, true point C, I'm going to draw a line. Now I'm going to indicate that in, again, I'm going to use red and a broken line here. Okay, so this distance from C to the top of the development of the true length of the hip, I then simply get my compass using C as the springing point. using C as the springing point, I get that as a radius. Okay, that is a radius. Now I can either swing it to the left or to the right of point C. It does not matter. It does not matter. Okay, so I'll show you in both instances here. So if I select this point here, and I will give this point here A, B, C, D here, and this is point E. Okay, so the dihedral angle, and I'll try and find a different color for the dihedral angle. I'll use blue. Okay, from point E there to point B, and point E to point A. Now, this now gives me my dihedral angle. That is my dihedral angle. Okay, so AEB is the dihedral angle of the hip, the backing angle. Where those two planes, this plane and this plane on the roof, okay, the roof surfaces, where they meet up on the hip, that gives the dihedral angle here. Okay, now if I flipped it over the other side and had the point here and connect that, again that's point E1 if you want to call it, connected it to B and A, it will give you the exact same angle as this. So it doesn't matter which side you flip it on, okay, it still gives you the dihedral angle. Okay, so this here, when I label it, that there is the dihedral angle. This here, that's the plan. So plan, elevation, end view. Okay, plan, elevation, end view, dihedral angle. This is true length of hip. This here is the plumb cut of the hip. This here is the seat cut of hip. Okay, now again, on elevation here, this is the common rafter here on plan. And likewise, common rafter, common rafter, common rafter on plan. But the true length of the common rafter is simply here. Okay, so true length of common rafter. This here, that's the seat cut of common. And this here, this angle here, that is the plumb cut of common rafter. Elevation, the plan, the end view. We have on plan the hips, the ridge, the wall plate on plan. I've pulled the true length of the common rafter down onto the horizontal, brought it down. I brought it down there to the plan. Okay, so that there is the true length of the common rafter here. I then brought this point here back to the corner points of the wall plate. That gives me here a true shape of this roof surface. I simply use the same length, true length, the common rafter that I've established here, and I've pulled that around. Okay, brought the ridge point here out to meet it, okay, vertically, and that gives me the point here, from this point here to this point here. It gives me the true length of the hip. It also gives me the top point here of the ridge. So I bring that across, bring this ridge point out to meet it, and where that meets it there, I bring it back to the corner point here. That there is the development of the roof surface, this roof surface here. So I'll indicate those two as, say, roof surface A and roof surface B. Okay, so A and B. So as a true shape, this here, I just shade it in very quickly. That there is a true shape of roof surface A, and this here, if I shade this in, this is the true shape of roof surface B. Okay, so you've got the true shape here B, true shape here of A. Okay, and then on this one here, what I simply did was develop the actual, just the simple, the roof, the hip rafter here of the roof. So on plan, that's the hip length on plan. It's the run of the hip. From that point, I draw up a line at 90 degrees to the hip on plan. Come up the rise measurement, which I take from the elevation. Bring that point back to the corner of the wall plate here. Okay, and that gives me the true length of the hip. Okay, so what I do is I simply draw a line. I've drawn it here, AB. I'll put that in red here. Okay, so I'll actually keep on, maybe put it in blue. I think this is blue. So AB is drawn in at 90 degrees to the hip on plan. Okay, that gives me points A, B, and C here. Okay, from point C, I draw a line at 90 degrees to the development of the hip here. That gives me point D. Then using point C as a springing point and point CD as a radius, I pull that around, I pull D around, and I establish point E here. Then I simply connect A to E and B to E, and that gives me the dihedral angle. Okay, this is the dihedral angle here. Okay, so I think that finishes the video on this. I hope you found it useful. Thank you.